and I'm going to step you through taxonomic classification in this series of little videos that are part of analyzing a metagenomic sample. So what we're going to be looking at is a stool sample collected from a patient who had had a kidney transplant. The taxonomic classification service that we're going to use is in the Bacterial and Viral Bioinformatics Resource Center. And it is based on this particular publication, which is by Liu et al. It comes out of the Salzburg lab, their bioinformatic powerhouses, and it's using Kraken software. So the BV-BC Taxonomic Classification Service, why I like to use it is I don't need to be a bioinformatician because I'm not one, and I don't need to know how to use command line because I don't know how. It's a web interface that's very easy to use and returns some great results. So for those of you who are like me, and you have this data and you struggle to analyze it, if you can't hire someone to work in your lab, this is a great resource. If you're a computer scientist that has no problem running command line, you can just download the pipelines yourself and run them. Okay, but this particular taxonomic classification service uses several bioinformatics algorithms, and you probably don't want to know all of these, but there they all are. It provides analysis for WGS, which is whole genome sequence, and 16S if you're looking at the ribosomal RNA, and some people do those kind of analyses. It only works for sequencing reads. If you have assembled data, it's not going to work. You're going to have to look somewhere else. It utilizes several databases, Kraken-2, which comes out of the Salzburg lab, BV-BC, which brings together a lot of diverse databases. And then if you're looking at 16S data, Silva and Green Genes. This service returns job results that include tables, plots that you can use for publishable figures, and it gives you alpha and beta diversity metrics. This is basically how the whole thing works. I created this thing and I think it's really good for me to visualize what's going on. So if you're starting with a whole genome sequence, or if you're starting with ribosomal RNA, it both starts with paired or single reads. And you can also use reads from the sequence read archive. If you get the run number, you can submit those. It first looks at read quality, so it generates a fast QC report. Now, if you're doing whole genome sequencing, you can ask it to align it to the host genome, remove the reads, and then look at those quality. But you don't have to put that, so it'd skip it over. It would give you the leftover reads, and then it would go into Kraken-2. If you're doing ribosomal RNA, if you have those kind of sequences, it would trim the reads and give you a read quality from that, and then it goes into Kraken-2. Now, Kraken-2, depending upon what you choose, because you could look for straight species identification or microbiome. In RNA-seq, it just has one thing. You get a Sankey plot, you get a multi-sample comparison table, chronoplot, you'll get a multi-QC report, and if you just choose species identification, you get a summary table. If you chose microbiome, you would get an abundance estimation using Bracken that results in the alpha and beta diversity. And then when you're doing 16S, you get all of these anyhow. So this is what the landing page for the service looks like in BV-BC. And we're going to go and submit some jobs. And then the downstream things are the visualizations that show you what is in that sample. So I think you'll like it, and I think it'll be a powerful step in your analysis. There's some diversity statistics as well, so we'll discuss that. So join me in the next video. We're going to submit the job. So thanks. See you then.